the question, there is a circumscribed quadrilateral. The name is not given in the question, but we have to give the name for doing the proof. So I have given the name to this quadrilateral as A, B, C and D. Right? So what we have to prove, that if it is a circumscribed quadrilateral, then the opposite side AB and BC makes an angle of, makes supplementary angle at the center. That means if this is the center, then the sum of these two angles should be 180. This we have to prove. And similarly, these two opposite sides, that means this one angle and this one angle, the sum of these two angles is also 180. Right? So we have to prove this. Now one important point here which you have to note down, that is, this is not a straight line. Right? A to O and O to C. These are two different line segments. This is not a straight line. We cannot take these as the vertically opposite angles. Right? So just you have to take care of this thing. Similarly, OB and OD again are not a straight line. They are not forming a straight line. Right? So now what we have to write in the equation? ABCD is a circumscribed quadrilateral to the circle with center O. So this is the given. Now what we have to prove? We have to prove that angle AOB plus angle DOC is equal to 180, or angle AOD plus BOC angle is 180. This we have to prove. I hope you understand the given and the proof. Now, for doing this proof, we have to construct here something, and the construction will be, we have to join these points with the center. So I am giving the name to the points. Let's say P, Q, R and S. Now after giving the name, we have to join these. Join OP, join OQ, join OR and join OS. Right? So if I want to write P, Q, R, S as a point of contact, P, Q, R, S are the, if I am writing because I have taken the name, if P, Q, R, S are the points of contact, then with the circle, then join. What we have to join? Join OP, OQ, OR and OS. Okay, now we'll do the question. We'll start doing the question. You have done this kind of thing in previous question also, when there was a question in which we have made this triangle and this triangle congruent. So you can do it easily. In these two triangles, PB equal to PQ, first thing. Second and third thing, you just have to find. Still, I will write here start here writing the proof. I am taking in triangle PBO and triangle QBO. You have to tell me other two things. I told you one thing, PB equal to PQ, and why PB equal to PQ? The reason you know, I hope you know that the tangents drawn from an external point are always equal in length, right? So tangents drawn from an external point are equal, or you can write equal in length. Okay, so this is the first one. Second thing, it's very easy. OB equal to OB, that's it. So OB equal to OB, what is the reason? The reason is common. OB is common, and third one is you can take OP equal to OQ, or one more thing you have, these two angles are of 90 degree because radius is perpendicular to the tangent. So you can take either one of them. So I am taking here. Third, I am taking OP equal to OQ because radii of the same circle are always equal. Okay, so OP equal to OQ, these are the radii of same circle. So from these three things, we can write that triangle PBO is congruent to triangle QBO, and by which rule? SSS. Okay, after making them congruent, what we have to take here? We have to take angle 1 equal to angle 2. And why these two angles are equal? Because if the two triangles are congruent, then the rest of the parts are also equal, which we have not taken. Right? So angle 1 equal to 2 by CP CT. Okay? Similarly, you can prove this in rest of the triangles in just in the same way. Okay, I can do that. 3 equal to 4, 5 equal to 6. I will write it here. 3 equal to 4. Let's say this is number 1. 1 equal to 2. Then 3 equal to 4 is number 2. And I have to write similarly, and then 5 equal to 6, this is number 3, and 7 equal to 8. Okay, so this is number 4. Now the question is very easy. You just get in just coming 1 minute. So you know that on a point, the angle is always, if I have this point, the angle around is equal to 360 degrees. So here also, if O is a point, then all of these angles makes an angle of 360 degrees. So at point O, angle 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 should be 360 degree, because this is the complete angle, and complete angle is always of 360 degree. Now from these equations we have 1 equal to 2, 3 equal to 4, 5 equal to 6 and 7 equal to 8. So if these are equal, I can write, in spite of 1 plus 2, I can write 2 as 1. In spite of writing 2, I can write 1 because 1 is equal to 2. So this will be equal to twice of 1. 1 plus 1, twice of 1, because 2 is equal to 1. We have just proved it. In the same way, this I can write as twice of 4. Why I have written 4 and not 3? Here also you have to note down, because I want to get the angle AOB and this angle DOC first. And in AOB there are 1, 8, 4 and 5. So I have to remove 2, 3, 7 and 6. Okay, so you just take care which angles we have to remove. We have to remove 2, then we have to remove 6, we have to remove this 3, and in the last is 7. So which angle we have to remove, you have to note it down so that you can do the question. So here also we can write it as twice of angle 5, and this will be twice of angle 8, and this all will be equal to 360. And can you take common here? Of course you can. And after taking 2 common, you'll get 1 plus 4 plus 5 plus 8 is 360, and 2 ones are come here and now what you can do, you just have to write 1 plus 8. This 1 plus 8. Can you give me the name of this triangle? 1 plus 8. 1 plus 8 is AOB, right? So angle AOB. And 4 plus 5. What about this angle from the figure? 4 plus 5. This will be DOC. Okay, so I will write here DOC, and which was equal to 180. So we have proved our first part. Okay, sum of these two angles is now 180. And in the same way, similarly, we can prove that AOD angle plus angle BOC is 180. I hope you understand the question. Thank you.